Good morning. This is a short video that I've created to talk to you a little bit about the purpose of doing unit conversions and give you some examples of when you might do those. You actually use unit conversions quite often in physics because most of the measured or given values that you have aren't in the same units, and you need to convert them so that they are in the same units so that they'll work out properly in the problems. Let me show you what I mean. These are the kinematics equations that we use most often in physics. These are the equations that relate together variables like velocity and acceleration, time, and displacement. In order for these equations to give us answers that make sense, the given values that you deal with must all have agreeable units. Let me show you an example of what I mean by that with this first kinematics equation. This first kinematics equation relates the final velocity to the initial velocity of an object and the acceleration that it has and the time that it's accelerating for. I could solve for the final velocity of the object if I knew the initial velocity, the rate of acceleration, and the time. If I'm doing a problem where the initial velocity is, say, given in feet per second, and then the rate of acceleration is in feet per second, and the time that it's been accelerating for is in seconds, well, this is going to give me a pretty logical answer, because this seconds will cancel out with one of those seconds. When I do that multiplication, I'll be adding together feet per second, and I'll end up with an answer that is in feet per second. Well, what about the situation where the initial quantities don't have agreeable units? Let me show you another example. Possibly the initial velocity is given to me in miles per hour. The rate of acceleration is in meters per second, and the object's been accelerating for some time that's expressed in hours. Well, even though this equation still holds true, this relationship still holds true, that initial velocity plus acceleration times time gives you final velocity, I'm not going to get a very understandable answer with this because these units aren't going to cancel out and add together properly. So in order for me to be able to evaluate the answer with these numbers, I would actually need to convert these units so that they were all agreeable. So let me show you a real example with some actual numbers to see what I'm talking about. Okay, so let's take a look at this example. In this example, I have a car that is accelerating at a rate of 1.6 meters per second. That's about, 1/6 the rate of acceleration of gravity, so that's not really a super high acceleration. And I want to know how long it's going to take that car to go from 80 kilometers per hour to 110 kilometers per hour. Well, the kinematics equation that I'm going to use to do this problem is the same one that I used in the previous slide, except I'm going to rearrange it for a different form. If I rearrange that kinematics equation for time, I actually come up with final velocity minus initial velocity divided by the rate of acceleration. Okay, and if these numbers that I had to start off with were all in agreeable units, I could just plug and chug and put that in, and I'd get a nice answer. It was some understandable time unit. However, that's not going to be the case here. The problem is, if I put in kilometers per hour on top and meters per second on the bottom, the units aren't going to cancel, and I'm not going to be left with some understandable unit of time. I'm actually going to have some really weird convoluted units. So the best thing to do here is to convert either the rate of acceleration into kilometers per hour, or the velocities into meters per second. Frankly, I think it's just easier to convert the velocities to meters per second because it's a pretty quick and simple conversion. And I don't know, converting accelerations into different units can sometimes be a little bit tricky. So that's what I'm going to set out to do here. The process that I'm going to use here is a pretty standardized process that you use really at all levels of physics. You'll find out that even when you get into higher levels of engineering, you go through this unit conversion process, sometimes just to kind of think through the logic of a problem to see if it makes sense. So what I'm going to do is I'm going to change 80 kilometers per hour 0.2 meters per second. And I'm going to do that by multiplying 80 kilometers per hour by a series of fractions that will actually change the kilometers into meters and also hours into seconds. The way I do that is by, again, rewriting my original value with its units, and then I'm going to multiply it first by a fraction that will change the kilometers into meters. Now, the fraction that I'm going to use has to be something that shows an equivalency, meaning, you know, I have to use some equivalent relationship between the unit that I have and the unit that I want to get to. And so I happen to know a really, really good equivalent relationship. I happen to know that 1 kilometer is 1,000 meters. By definition, that's what a kilometer is. A kilometer is 1,000 meters. So really, this quantity is what we call an equivalency. Okay, that means that you know, this is really just the same as writing down the number 1 here, because 1 kilometer is equal to 1,000 meters. But the beauty of doing this is I'm going to actually now change the numerical measurement here while still retaining the original value. Okay. By the way, the reason I put kilometers in the denominator here is because I want kilometers on the bottom to cancel out with kilometers on the top. If I stopped right now, I would actually have an answer that was in meters per hour. Okay. You know, 80 times 1,000 is 80,000 meters, and so that would be 80,000 meters in 1 hour. If you went 80 kilometers in an hour, that's the same as saying you'd go 80,000 meters in an hour, which kind of makes sense. Well, I'm going to continue on this process because now I want to change the hours into seconds. Now I'm putting hours on top so that it will cancel out the hours that's on the bottom of my original unit value. You know, in math, whenever you want to cancel things out, you know, things that are on the bottom of fractions will cancel out with things on top of fractions. So you can decide how you're going to write this fraction depending on what you want to cancel out. Now, I need to know an equivalent relationship between hours and seconds if I want to use this as an actual unit conversion. Well, this is one of those ones that you're probably just going to need to memorize because we use it all the time in physics. Think about this. In 1 hour, there is 60 minutes. And in 1 minute, there's 60 seconds. What that really means then is that in 1 hour, there is 3,600 seconds. Okay, that's just a conversion that you probably just want to remember because we use it all the time. Okay, so when I go through the process now of taking 80 kilometers per hour times 1,000 meters over a kilometer times 1 hour over 3,600 seconds, I will have converted my kilometers per hour units into meters on top and seconds on the bottom, meters per second, which is what I wanted to do. Okay, so now what I need to do is just carry out the math. What I'm going to do is I'm going to take 80 times 1,000 times 1. I'm just multiplying everything that's on the top of these fractions by the original value that I have. Then I'm going to divide all of that by what's in the denominator of all these fractions. So 1 times 3,600. Okay. When I take 80 divided by 1,000 times 1 and divide by 1 and divide by 3,600, that's really the same as taking 80,000 divided by 3,600. I get 22.22 repeating meters per second. Okay, so what I basically just found is that a velocity of 80 kilometers per hour is the same as 22.22 meters per second. I just converted that. Okay, I'm going to want to carry out the exact same conversion for 110 kilometers per hour. And when I do that, I really am going to just do the exact same conversion that I did there down here. That math will yield an answer of 30.55 repeating meters per second. Okay. Now what I've done is I've found my initial velocities and my final velocities in meters per second. Those meters per second values will now be agreeable with the meters per second value that I have in my original problem. If I roughly just put these numbers in, I'm just going to do this in my head, 30.55 meters per second minus 22.22 meters per second is 8.33 meters per second. When I take 8.33 divided by 1.6, I don't know, you're talking about roughly 4 to 5 seconds, right? Somewhere around in there is how long that acceleration is going to take. Which actually, now that you think about it, to go from 80 kilometers per hour to 110 kilometers per hour in 4 to 5 seconds, that's a decent little rate of acceleration that you're going to have to do that. Well, anyway, look, I hope that this little tutorial helped to clarify some things about unit conversion for you. Hopefully it gave you an example for how you can do this, and also help to help to make you feel more comfortable with doing that. Good luck and have a great day.